Hello everyone, this is Chen. Uh, the title for my object is Differentiable Network Architecture Search for Object Detection. So the motivation is like this one. Uh, Object detection performance is really depend on the network architecture it using as backbones uh, and as feature extractor for the detector. So in usually uh, people taking the network architecture which is optimized for image classification task like the VGG or ResNet, and then using this kind of network as feature extractor in the object detection project. Uh, but the network which is optimized for image classification task cannot guarantee the performance on object detection because these two tasks is quite different. So in this project, I'm trying to uh, use the automatic network search algorithm to search for the network for object detection. Uh, and the second motivation is that all previously network active search or NAS algorithm you only search on a proxy task and then transfer to the target task. So in this project, I'm trying to directly optimize on the target task. So the difficulties for this project is that uh, first is very time consuming. Uh, the conventional NAS algorithms are prohibitively computational intensive, require a training thousand or model on target task in a single experiment. Because you're only using the reinforcement learning or evolution. So you need to train this model more than 1,000 times. Uh, and the second is that even train a single object detector, you only need several days and GPU. So this is two difficulty in the project. So in the whole project, I did three experiments. Uh, First is to train the fast accident detector uh, using the human designed network architecture, like the ResNet 101. So this is using as a bottom line. Uh, the second is that I search the CNN block on image classification task, and then stack this searched CNN block into a network bounds, and then put the RCN on the top and train them as a whole from scratch. This the second way I call it indirectly NAS, and the third way is that search CNN block directly on the object detection, which in this case I train on the Pascal VOC, and then stacked the searched CNN building block into a network, and then trained fast CNN from scratch. So yeah, so this is this three experiments what I'm doing. Uh, yeah, in the method, as I mentioned, reinforcement learning and evolution they are very time consuming and they are very uh, computational expensive. So in this project, I'm using the a new I'm using the idea from a recent paper called the differentiable architecture search. Uh, so how is this search done? Is here. So in a in a cell block, uh, uh, the operation on the edge are initially unknown. So here every node is a feature map, or you can say activation, and every edge is a operation, and yeah, and every node can get the uh, operation can be transformed from all previous nodes. Uh, so usually this kind of problem is not differentiable because the searching space is discrete. And then in this paper, they using continuously relaxation on the searching space uh, by replacing a mixture of candidate operation on each edge. So each edge is a combination of different type of operation. So the candidate type here is like 3 by 3 convolution, uh, 3 by 3 separable convolution, 3 by 3 max pooling, 3 by 3 average pooling, and identity, and zero. Zero means there's no connection between this node and the previous node. Uh, so the problem becomes jointly optimize the mixed probability uh, and the network weights by solving a bi-level optimization problem. So the mixture of probability is the network architecture, and the network weights is the real weights for the network. And then after you get this kind of mixture probability, we can induce the final architecture from the learner mixture probability. So let's say from 0 to 1, right now you have 3 ways, right? Just get the operation which have the maximum probability as the connection between 0 and 1. So basically that's the idea. So how I using this one network search in fast RCN? Basically it's pretty easy. I stack several of this mixture type of operation into a network as backbones, and then I attach the fast RCN network, which including the region proposed network and the RCN detector on the top of it, and then train them together. So during the training, the optimization algorithm will not only optimize the weights in the network, but also search the best architecture for the whole project. So here is some searched CNN block. Uh, every block has two kinds of cells. One is called normal cells, which the input and output are same dimension. The second one is called reduced cells, which the output is by 2 times downsampling from the inputs. So you can see the architecture is here, which is which is the result from my training. And the interesting part comes. So I done these 3 training and evaluated them both on the Pascal VOC. What surprised me is that the human designed ResNet 101 get the best performance. The second experiment, which I trained on image classification and transfer to detection, get the second place. The idea I propose, which is directly trained on the object detection task, it performed the worst. So that's out of my expectation, and it's really surprising. I guess the reason is maybe the NAS training process is still very fragile and subtle, and not all hyperparameter and the training strategy needed to be carefully designed, and also the searching space also need to be designed. Here I'm using a very limited operation as to construct the searching space, and for example, like 3 by 3 convolution, 3 by 3 pooling, and this operation is useful in the image classification. Maybe for the task of searching architecture for object detection, the searching space also needed to be different. So in the future, another direction is that instead of searching CNN a building block, we can directly search the whole network architecture. Yeah, that's it. Thanks.